of this lecture, at the end of this lecture, we will apply the data analytic in our engineering day-to-day practice. I want to say that this workshop should be held from time to time. And I want to charge other divisions that they should wake up and bring out ideas that will adopt, that will improve, that will harness our engineering practice. The world is waiting for engineers. There are a lot of opportunities there waiting for engineers. It's just for us to tap into it. I want to say that the AI war, that the AI we are practicing today, it already, I know people is creating fears. People are thinking that they won't have jobs to do again. I want to say that we, the engineers, from time to time, from age to age, will have what to do because the war is full of problems and every problem is looking for solutions. And engineers are the solutions to the war problem. I want to say a very big thank you to the paper presenter, the person that will present, that will anchor this workshop. And I want to charge you that whatever idea you add, whatever idea that you bring out today, we in the Nigerian Society of Engineers, we will take it and we will make sure that we will expand and enlarge it. This workshop will not just end in this Zoom. We will take it into a practical experience and we'll make sure that in our branches, in our various places of work, we'll implement it and we'll put it into practice. Thank you so much, everyone that have joined this webinar. I want to wish you a very useful and successful deliberation. Thank you and welcome.
Yes, thank you very much, Chairman NSE Uyo Branch, for that truly inspiring address. I'm sure in our hearts that definitely will set the tone for today's workshop. Without further ado, let me now invite the Chairman of Cross River States Chapter, Engineer NSCHE Orok, for his opening remark. Chairman, Mr. Chairman, please.
Thank you very much, Engineer Ukoben. Let me get straight to the point. Ladies and gentlemen, you're all welcome to today's workshop. It gives me great pleasure to welcome you all to the Data Analytics and Application in Engineering Practices Workshop organized by Nigerian Society of Chemical Engineers in collaboration with the NSE Uyo Branch. This workshop comes at a time when the integration of data analytics in engineering practices it's essential for driving innovation, efficiency, and sustainability in our industries. As we converge to explore the intersections of data analytics, engineering, and technology, we are presented with a unique opportunity to leverage data-driven insights and professional pursuits. The knowledge and understanding gained from this workshop will undoubtedly be instrumental in reshaping our approach to engineering practices and problem-solving methodology. By embracing the principles and applications of data analytics, we aim to unlock new frontiers of efficiency, optimization, and informed decision-making within our respective field of expertise. The evaluation and invaluable insights and practical knowledge to be gained thereafter will empower us to navigate the rapidly evolving landscape of engineering practices. So I want to extend my sincere appreciation to our esteemed collaborators, the NSE Uyo Branch, anchored by our very dynamic engineer, Umoh FNSC, and our distinguished presenter, Mr. Umoh, and also other participants for their commitment and support for this groundbreaking initiative. I am confident that this workshop will enrich our professional competencies and foster meaningful dialogue.
Anthony, please come back with that.
For the advancement of engineering applications. I encourage all participants
by Mike, and I'm sure he has completed it
in the session.
Before he left for,
generously shared their insights and embrace. I encourage all participants to actively engage in the sessions generously share their insights, and embrace the spirit of collaboration to maximize the benefits of this workshop. Once again, a warm welcome to all participants, and I wish us all a productive and enlightening workshop. Thank you and happy new month. Thank you very much.
Yes, thank you very much, Mr. Chairman, Akwa Cross River State Chapter Engineer Chemistry Rock. I think both chairmen have actually given us some insight into, or a preview, if you will, into today's workshop. And of course, we are now in an age-driven, world where we are, bolstering towards innovation, efficiency, and the need to better optimize more complex systems. I can assure you, all our participants and distinguished members today, that there's a lot of appetizing, information and insights that will be shared by our webinar instructor today. But before we have the presenter delivering the training for this webinar event, I would now like to invite Engineer Dr. Esidikot Esangobong, Assistant Technical Secretary, Akwa Cross Chapter, to kindly read the citation of today's webinar instructor. Thank you. Engineer Dr. Esidikot, please, are you with us? Please, I believe you are speaking to a muted mic.
Confirm you can hear me?
Yes, we can hear you, Doctor. Please, you can proceed.
Apologies. Trying to manage multiple devices without unnecessary interference. A very beautiful good morning to all the participants. This is the abridged citation of Odudu, who is going to serve as the instructor for today's webinar. Odudu is an experienced data analytics professional. Looks like it's the appearance at the background. The host, is it possible to mute people who are not speaking? Looks like we're having interference at the background.
The admin should do that right away. Mute everybody except the speaker.
Yes, please, before the Assistant Technical Secretary proceeds, can we kindly check and ensure on our part that our mics are muted, please? Very well. Assistant Technical Secretary, please, you may proceed. Thank you.
Okay, once again, a very beautiful good morning to all the participants, and thanks for finding time to be part of this webinar. This is the brief citation of Odudu, who is going to facilitate or serve as the lead instructor for today's webinar. Odudu is an experienced data analytics professional with a strong background in data analysis, with bias for analysis of engineering data. He has utilized data analytics as an instrument to improve engineering practices, enhance equipment reliability, and improve maintenance efficiency and effectiveness. A native of Abang local government in Akwa Ibom State, Odudu holds a bachelor's degree in computer science from the University of Uyo, Akwa Ibom State, and a master's degree in information system from Warwick University, Coventry, United Kingdom. He has attended several local and international professional courses and holds several professional certifications, such as Certified Information Systems Auditor and Project Management Professional. Odudu has honed his skills in data analysis, data visualization, and data warehouse project implementation, as well as operational data analysis over the past 20 years. He brings a wealth of expertise to the table. He has invested several years of his professional career in personal development, enhancing human capacity, and driving continuous development. I think today's discussion is actually one of those occasions that is going to also drive his passion for enhancing human capacity development. He is happily married with children. Fellow engineers, ladies and gentlemen that found time to be part of this webinar, permit me to present before you Odudu, the instructors of today's webinar, to take the lead. Thank you.
Good morning.
Good morning, sir.
All right. Confirm I am audible, clear, loud.
Affirmative,
Loud
sir.
and clear.
All right. Thank you. So Esan, are you going to share your screen?
You want to share the screen from your end?
No, share from your screen. I think I'll be more comfortable that way. All right. I don't know whether I'm going to do a better job than the chairman that that spoke and talked about the purpose of this seminar. I think he did a better job and is better prepared for this than I am. I am more comfortable sitting behind the screen, touching things, working Excel, and all the other stuff, and all the other applications than speaking in front of people. So should we hand over today's presentation to the chairman?
No, you are the SME.
All right. Okay. Okay, so let's go. So I didn't want to make a table of content or anything for this, so that's why the first screen there has what we will try to do today. Try to look at the power of data, and how we can use that to drive, like the chairman said, drive innovation, optimize engineering workflows, enhance our engineering toolkits. We will look at the foundation of data analytics just a bit, and then we'll try to see how we can use that to gain insights to fuel breakthroughs and strategic decision making. I know I had to trim this a bit. I hope I can make the 1 hour that I'm given. Of course, I want to also warn us that every page that we will open is a potential lecture on its own. So I'll do the best I can to summarize. And you know, in summarizing, we lose some information. But if you have any questions, we can go ahead and talk to them one by one. How do we want to do this? Do we want to wait till I finish, or do we want to interject with questions as I go?
Uko will moderate. I think after your lecture, you will have opportunity to get questions from participants. Is that okay?
Yes, that's okay for me.
All right.
Absolutely.
Okay. All right, so next screen, please. So what's actually data analytics, and specifically when it relates to engineering? it's nothing new, right? It's something that we've been doing. It's just that sometimes we didn't formalize it. So it's just the use of statistical and computational methods to extract insights, just to give that engineers that power to make data-driven decisions. I would want to rephrase that a bit and call that fact-driven decisions, right? Because that data, as it comes, may not make sense to anybody until you are able to articulate, find meaning, and then bring out the facts so that you can use that to make your decisions. Also using that insight to optimize engineering processes, manufacturing processes, and the rest of the stuff. And then driving innovation across fields like manufacturing, infrastructure, and R&D. How does that drive that? We would see how do we drive innovation with that data? We would see as we go ahead. So next screen, to differentiate, to put things in perspective. I have 2 slides that talks about reporting and analytics. They are not actually 2 different things. They are just one continuous stream of processes, right? Or process. So if you are looking at your report that we write, it just shows you what's happening. Formatting, summarizing information. Okay. You are just sending sometimes emails or hard copies, reporting what has happened to your bosses. So let's say, for instance, you had a project, and at the end of the day, they said, oh, give me a daily report, give me a monthly report. You are going to report progress. You are going to report results. We were able to do 90% of this today. We were able to do 80% of the work today. What's remaining is 20%. It's just translating the work that you've done, the data that you've collected into information, because by the time you take your measurements of the work, okay, so I had 80 kilometers of road to do for the civil engineers. I've been able to do, I have 100 kilometers, I've been able to do 70, that's 70%, okay, factoring in other stuff. But when you're looking at analytics, you are looking at the other spectrum. What am I using this report and the data for? So I'm not just saying what's happening. Okay, so the data is there. Why is it happening? What are the questions that come out from here? So we had projected we were going to do this. We're not able to do this. Why were we not able to do that? So like the example of road construction that I used, you may have gotten to a swampy place. You were faster when you were on dry land. You got to a swampy place, to a swampy area. You now have to explain, okay, so that place was swampy. So why were we not anticipating? What would we have done next time? You question, interpret what that data means. What does 70% mean? Okay, so we pull those results to answer questions. We pull those, once you pull those results, it's beyond 70%. What is behind the 70%? And how can we use that to answer the questions? Why were you not 80, 75? Why were you 70? And it offers, analytics helps you to answer questions and also recommend possible. So for next project, what are we going to do? For instance, so I have a road that was constructed in maybe around Okanafon. Then I'm going to do another road in Etemekbo. How am I going to apply that lesson? What recommendations will come? What actions? That is what analytics does. Okay. So next screen, please. So apart from looking at reporting and analytics that way, we can also look at it with respect to the purpose and outcomes. So if you look at the graph to your left, it shows you where the intersections between reporting and analytics. So if you look at that, you see that analytics is more in the strategic realm, whereas reporting generates more operational or tactical value-focused information just for us to keep running. Yes, if you look at that, you also see that there's a crossover, but generally reporting helps with operational items. So operational items like efficiencies, process monitoring, improvement, auditing, quality control. Whereas if you look at analytics, it is aimed at generating insights, like I said before, that will lead to decisions and action. Analytics, the content of analytics is designed to facilitate valuable insights. And most of the times, you would see that itself is at the speed of thought. Okay, so what am I talking about speed of thought? As we are asking the questions, we are answering, we are generating insights, we are generating decisions as we go. Oh, this is what happened. Why did it happen? As we go on, we are changing, we are adapting, we are moving. Okay. And then if you like the chairman was talking about, we moved. So analytics did not just move, it moved with technology, because some of the analysis that you want to do, you might not be able to do that on paper. And given the fact that we are thinking about money and how what the children will eat and all that every day, will not be able to process all that information using our brains, despite the fact that the brain has the capacity more than the computer. So we will need the zombie of the zombiness of the computer, the routine of the computer to be able to analyze this information, so we can now use that to make our own decisions. The chairman also mentioned something like that. Say, oh, the computer will not take away our jobs. No, because we are the ones that will decision making and problem solving. And the outcomes is just information that reporting will give you. But analytics will enable you to optimize your processes, predict outcomes, and drive innovations. So having done that differentiation, I think we should look at the next page. What does analytics do for the engineering toolkit? I actually like that picture, digitizing the spanners and the screwdrivers. So analytics becomes your digital spanner and screwdrivers, helping equip engineers with powerful tools to tackle complex challenges. As we speak today, the bridges is like, okay, so growing up in Nabak, I think I've seen like 3 bridges. So there was a bridge that was down there. There's a bigger bridge. There is a longer one right now that I would prefer to call flyover. So every day, the bridge got bigger and bigger and bigger. And that's what is happening in the engineering world. Everything is getting bigger and more complex. My father's transistor radio that we had those days, we used to open the back and use screwdriver to fine-tune the big capacitors to be able to get tweeter or bass out of it. Right now, you cannot even see capacitors if you open any radio, because they are so tiny, and that radio has become more complex and can do more. And that's what's happening in the engineering world. So everything is bigger. So as it grows bigger, we have to be able to harness other tools to be able to work with bigger projects, to be able to deliver more, to be able to compete. All right. So data analytics is one of those tools that will help engineers unlock data-driven decision making to optimize your processes and drive innovation. It empowers engineers as a tool. It empowers engineers to uncover hidden trends, model scenarios, and predict outcomes with precision. And well, I will say that with the caveat too, because the precision that you require, the accuracy, is also dependent on the quality of the data that you have. It enables data-driven or fact-driven problem solving, leveraging statistical and computational methods. And one of those things I talked about was the fact that yes, there are things that you can do. There are things that you can do on paper. There are some calculations these days that the data analytics application would be able to handle that you can use like a year and you will not be able to compute. But that process, the computer or whatsoever you are using, the module or the model that you are using will produce that in an hour. Okay, it transforms the engineer's toolkit, equipping engineers with powerful data analysis capabilities, and provides a competitive edge by harnessing the insights hidden within engineering data. So I would say data analytics helps and empowers engineers to uncover hidden patterns, model scenarios, and predict outcomes with precision. The precision is important. With precision. And that precision, like I said, is important. Okay, next page, please. So some use cases of data analytics in engineering. You look at civil engineering, I've already talked about road construction. But in civil engineering, you can use data analytics to optimize infrastructure design. So we've seen a lot of 3D diagrams, right? Now, going beyond the 3D diagrams that we see, we can digitize it, get data points from those 3D diagrams, and use data or the optimization, changing some of those parameters to see how those 3D diagrams would behave. So if you have a structural diagram, you can with proper data analytics, you can simulate earthquake. You can simulate shear and stress on that structure to see how it works. Some people build scaffolds, and you see that there are some scaffolds I have seen. The structure of that is such that you would need to put it in a system, design it in a system, and test it to make sure that it's safe for people to climb. Then data analytics helps with that. Improves construction efficiency. You can predict the maintenance needs for roads, bridges, and buildings. So analyzing sensor data for bridges. So there are bridges right now that are built and digitized. What we do is we put sensors on the bridges to measure something like vibration, and vibration will tell you what the state of the slabs and the vibration dampers on the bridge are. So those sensors bring data. Buildings too. There's okay. Sorry for that interruption. So having those sensors on those bridges and buildings, like I said, would help detect early signs of wear and tear, and it will enable us to proactively have a schedule to go maintain the bridge and buildings, and that will help us to improve the health of that of the bridges and buildings. So you will hear something like some months ago, we heard that the Third Mainland Bridge was shut down. Yep, I know that was as a result of reports of vibration and all that. But you could capture those insights. If we had a sensor on those bridges, you could even capture it months before humans would start to sense or feel the vibrations. If you had those, and put that on your computer and analyze that data, you will be able to sense the vibration before anybody, any human can detect it. And that itself will also help you shorten the length of time you will need to shut down that bridge, because if you catch it early, you can repair it fast. Then looking at mechanical engineering, enhancing product design, optimizing manufacturing processes. You can use machine learning algorithms to identify bottlenecks and inefficiencies in production lines. So machine learning is different from writing a program. Machine learning is having the system learn from data. So say, for instance, you have production data, you have other temperatures and all that. So the system, you put that and you teach the system, when you see this, do that. If the temperature is high, slow that down. The system learns from that data to adjust itself according to the parameters that it has. So in that mechanical engineering space, you can identify bottlenecks and inefficiencies in production lines, and therefore be able to increase your throughput. You can also predict equipment failures. So we talked about vibration in the civil engineering space, also in mechanical engineering space. So you have turbines with vibration sensors. You have turbines with fire temperature sensors. What they do is, so going away from having those sensors is having the system, a back-end system that can take that data and work out the issues that you have. Look at, so if I'm having this level of vibration, the system would say, okay, so maybe your bearing is, the system would prompt you and recommend actions. Check your bearings, check this, check that, early. And that will, if you check and you find out that one thing is spoiled, you can go change that one thing. If you do not utilize this, what happens? The vibration sensors you are not getting that data on time. You are not analyzing it on time. Your bearing will fail. That bearing failure would lead to some other, maybe shaft issues, and that will lead to oil leaks and all those kind of stuff. And by the time you get to that point, your downtime increases. So instead of changing bearing, you are now going to go and look at how to machine shafts or change shafts. Okay. Then in the electrical engineering space, of course, you can model and simulate complex power systems. So you have your power stations, you have where your sub-transformers are. You can model that in the system. And a simple case, putting that simply, is, okay, so if you have maybe a drop in power from a particular substation, you know what power fits, which you can simulate in the system to check, what does this fit, what does this bring, what this line that is coming, what power does it bring, how much power does it bring. So if it drops, a simple thing, the system can check and tell you that, okay, so these are the possible problems that you may be having. You have a drop from this line, the line that is coming from it to the line that is coming from Ikorabasi, or the one that is coming from Aba is the one that is the fault. That would precisely send the engineer and reduce the workload. So instead of checking everything, it tells you exactly where to go. Okay, so you can use that to detect anomalies and send the engineers to go work on specific things. It streamlines and reduces the contact points for the engineer. Okay, and then in the chemical engineering space, automation of industrial processes. We talked about machine learning specifically. Optimizing of industrial production processes, process modeling. We know the characteristics of each of the things that we are doing. A system, once you put those data in, with data analytics and with the proper model, the system you can optimize, you can, so as we are going, we'll hear about digital twin. You can have a computer model that you can do all your experiments, all your simulations on. You model it, and then when you are sure you have the output that you want, you can bring it to life on a live system. And that's what data analytics helps us to do. Okay, so having looked at next page, please. Sorry. So let's look at some key concepts and techniques in data analytics. We've already talked about reporting. So one of the things that we talked about was that reporting summarizes and gives you data. And you could just say that's descriptive analytics, summarizing, describing historical data to understand what has happened. So looking at measures, averages, percentages, totals, variances. But moving away from that, you get to the predictive analytics, using statistical models and machine learning to forecast future outcomes and behavior based on past data. So we've talked about the road construction. So we've done this before. This is what happened. This road that we said we will finish in 1 month, we didn't finish in 1 month. Why? Now, we can put in information. We can put in that information into a model for another construction to say, okay, so we have these parameters. Predict for me how long this project will take. Predict for me, I had said I'm going to use this volume of granite. I'm going to use this volume of tar. I did not use it. So because this changed. I'm putting it that change. I have gone to do my analysis. I've gone to take data for the new construction that we are going to do. We've done the soil test. We've done everything. Using this soil test and environmental impact data, I'm putting it inside here now. Show me, give me how much granite am I going to use? How much tar would I use? How long would this project take? How many people would it take? How much money would it cost? So using that past data and techniques like regression analysis and classification. And of course, we'll see the other ones when we get to the tools too. Something like cluster analysis. Okay. Then apart from predicting, okay, so I'm predicting what will happen. Analytics also prescribes, and that's what we call prescriptive analytics. Determining the best. So I'm using the data that I have. I've analyzed it. The system can look at different scenarios, like what we talked about. So if I do this, if it's this, this is what will come out. If it's this, this is what will come out. And using some optimization algorithms and simulations, it can prescribe a course of action. So this particular one you are doing, this is the way to go. This is what I would recommend. Of course, that recommendation is just there. It's up to the engineer to accept or reject, because at the end of the day, the computer can only recommend. We still have to use human knowledge, human experiences. Of course, for projects, there's always politics, the politics of the project to make informed decisions. But that is where our own individual and personal experience. Sometimes the computer will take its own decisions as a mechanical, or the data that you have will give you mechanical prescriptions. You will now have to humanize that prescription to suit where you are. So the politics of doing road in the north, the politics of doing road in the Niger Delta, they may be different. You have to understand that to implement the decisions that the system has given you. Now, the last one there is data visualization, presenting data in a visually appealing and easy to understand format through charts. Not just that, not just presenting that, right? After analysis and the description and everything, putting that there, there is this other aspect that you are having that visualization and you are able to tweak the parameters, the data in there, and you are seeing as those visualizations are changing. You, like we talked about in chemical engineering, modeling and modeling processes and all that. You can model that process. Visually, the system will show you the outcome. In graphs, it could show you, it could model like a tank with levels. It could model the other things. So let's say, for instance, you had a 3-stage separator. And say, okay, if I put in this, if I remove more gas, if I pump out water, what will happen? How does that play out with the other things? So it would show you those visuals. It gives you that opportunity, and it's about the easiest form, but it's the back end, and it's like basically built for end users, people that may not really want to delve into the data and the programming part of data analytics. So you get that visualization that you can tweak, and you will also see the results. So look, after having looked at the key concept, of course, like I said, each page that we are looking at here is potentially a presentation or two of its own. So we can talk more. There are other things I could break this down into a lot of other into smaller pieces, but I think this high level is good for me. So let's look at the next page so we can delve into a high level view of what it takes to even have the data analytics system that we're talking about. So I took an example of building a predictive model. So and this is the typical workflow that you will have, right? But for all systems and data, and for all data analytics systems, the workflow would not be quite different from this. It starts from defining what your problem is. What is your problem? What are you trying to solve? Now, how does that affect the project itself? That if you don't define your problems well, you'll find out that you will not be able to have the solution that you need. So in some establishments, you will hear people called business analysts, business process analysts, business systems analysts, whose duty, so let's say, for instance, you have engineers. Engineers may not understand the implementation that they want, but they know what the issue is. So the engineer would talk to somebody that understands the system, making the person, so it will be your duty to educate the person, making him understand the engineering side, He may not have the same knowledge, but at least understand it enough to be able to help you flesh out the problem itself. And then he will take that interpretation and then build the solution, build a model of the solution and review with you so everybody is on the same page. So building an effective predictive model or effective. Are we okay? Hello?
Yeah, go ahead.
Okay, sorry. Okay, so defining the problem or the problem statement is for you to clearly articulate the engineering problem that you want to solve using data analytics. The next thing will be to gather the data. This is what, so you will determine part of that description is, this is the problem, and okay, so if you want to solve this, these are the data points I need. Why do we need to choose or pick on the points that we need? We may not have all the capabilities to dump in all the data into the analytics program. So we are going to collect the data that we need. And after that collection, we want to clean. We want to clean that data. Explore, that's where we talk about preparation. Exploration is, okay, so I'm looking at the data. I'm trying to discover whether there are outliers in there. So after collecting the data, the general viewing of it, modeling it, maybe so you can use some statistical models to look at the fact that, okay, what's the mean, what's that, and then it will show you whether you have an issue in there. It will show you whether that data. So let's say, for instance, for when you explore the data, you may be able to see that where you are looking for input of 1 to 10, you now have a 12, and you will know that that particular one should not be part of it, and that will prompt you to go back to look at your data sets. And it could have been maybe somebody made a mistake and typed the wrong information in there, right? So exploration is visualizing and looking at that data to uncover patterns, and then you can also generate hypotheses from there. I have this is how it is. I've cleaned it. I've discovered that going by this pattern, this may not be correct. And then you can use that to generate your hypothesis. And then you want to model your data. You build a model that will fit it, and that is what the data analyst or business analyst helps with. He creates a model, and then together we can look at assess the model, put in the data, generate what we want to generate, interpret and communicate results, and then we deploy it. So the workflow goes from defining the problem, getting the data, cleaning it up, creating a model that you will use to analyze that data to solve the problem that you are looking at, then assessing that model to make sure that it will do what you said it should do, then interpreting and communicating that result, and then deploying it for end users. So I will just take us through a few things around the workflow. So collecting engineering data. First of all, what are the sources? What are the sources of engineering data? What are the sources of engineering data that we want to collect? Where do we get engineering data from? Sensor data. So like we talked about the smart bridge, you have sensors that will sense vibration. So you various devices and equipment have sensors that monitor performance, detect anomalies, and optimize operations. So we get engineering data from those. We have operational data that are generated from business processes, such as production records, maintenance work orders, supply chain data, and the like. We have simulations and modeling of data. So you have a computer-aided engineering tool that you use for virtual prototyping and testing. So you do the prototype in the system, and then you take your data points. Of course, the heights and all those kind of stuff that you do with. And the last one is the customer and user data, depending. So let's say, for instance, you are a consulting firm and you have built a system for a client. To be able to improve on what you are doing, you might need feedback from the users of your equipment. So you look at a company like GE with their turbines. They depend on usage information to be able to optimize their to be able to optimize their manufacturing processes. So you find out that sometimes they will receive some bad information. They will come to the system, collect that data, analyze it, and you will come and say, okay, this module, we are revamping it. We are changing it totally. In the car manufacturing industry, you hear of recalls. Those recalls, where of course they will build the car, test them, they will not be able to detect those issues until people start reporting accidents, failures, and then they will go back, look at what those customer and user information, and then they will now rebuild their system to give a solution to what that issue is. So you can get your sensor data, operational data, simulation, and modeling data. And the best, for me, the best one, of course, it usually comes with failure. It usually comes with sometimes with blood, because some of this customer data will be as a result of accidents or incidents. But that, for me, is the last point. What is your customer saying? Engineering does not exist in a vacuum, and we don't engineer for engineering's sake. We serve people. So it's important that we see the people that we serve as customers, get feedback from them to optimize our processes. The next page, please. After collecting the data, what you want, the next stage, like we looked at it, was preparing that data. Preparing includes cleaning, looking for outliers, removing duplicates, identifying and removing typos, converting data types. So let's say, for instance, where you were expecting date and you're having number format, if you put that in the system, you will have an issue. So you want that cleaning process. How do you handle missing data? Imputation. There are some things you are expecting. When you go there, you will not go into some field will be empty. What do you want to do with it? Do you want to replace with an appropriate value, or do you want to remove that particular field entirely so that it will not skew your data? Now, what people do with missing data, well, from my experience, is we have a benchmark. So we put that average, that benchmark in there, we plug it in there, so that we can have complete data. Then looking at the formattings, ensuring that the formatting is consistent. So if you have 2 decimal places, you maintain that. If it's 3, you make sure that every data you have will be to 3 decimal places. Okay. And then just applying, validating, making sure that that data, looking through it, making sure that that data is what you are looking for. So data quality is very important. Of course, it goes by the normal cliche that garbage in is garbage out. If you have the wrong data, whatsoever the information is going to bring is going to be wrong. And that will also affect the engineering decisions that you take. Another important one that I think I want to talk about is, we talked about exploratory data analysis. So that is that initial look at that at the data sets, looking at doing some exploratory data analysis to visualize, doing statistical summaries, like I said, to uncover patterns, outliers, and maybe discovering relationships between the data. So this one is there, this one is here. It helps you to have a grasp of what you are looking at, and it also helps with modeling. So looking at that, so you can be able to determine look at the data quality, the quality of the data you have, the distribution, the structure. So that helps you with building the model, and it also helps you with even interpreting what you are seeing at the end of the day. So this stage for me is very important, because this is where you look at the data before you put it inside the model. If you understand the model, you will have to understand the characteristics of what goes into the model, because it is the structure, the workflow, the workings of the model, and the characteristics of the data you are putting in that gives you the insights that you are looking for. And this is the last look at that data before it goes into the model. That's why I brought this out specifically. Now, oh, we are still at this. Please go. Go down. So we've talked about this, and we've talked about this. The next thing I want us to talk about. No, go up. All right. So looking at modeling itself. All right, sorry for that interference. Looking at the model itself, I want to say one thing, and that's, for me, is another caveat. We can model, we can create a model, we can do a fine job of whatever we are modeling, right? But models cannot capture every detail of the real problem. I've not seen any model. I have never seen any model that has captured every detail. Like I said, there are other things. So one of the things, there's one term I use. I call it socio-technical aspect of data analytics, or any project that you have. In fact, it's not restricted to social data analytics. Any project that you are doing, there's always a social aspect, and there's also a technical aspect. So you can capture that technical aspect in a model beautifully. But that social and the other things that are there, you will not be able to. So models cannot capture every detail of the real problem. That is why no matter what you do, data analytics and its recommendation cannot replace the work of a professional engineer. It can only aid. It can only even add to his skills and give him more money. Because the more efficient he is, the more sought after he will be. So engineers, we still need professional engineers. And one of the things that a professional engineer should know is, or know the limitation of the model. So if somebody is building it for you, you would need to ask, what is the limitation of this model? What are the underlying assumptions? Why do we need to ask these questions? Because when we have that knowledge, we will be able to incorporate that judgment into our own decision making. Oh, it has looked at this and this. It did not look at this. So I will tie the loose ends and then make an informed decision. Having said that, let's go into the tools. So we have statistical models to leverage, leveraging advanced statistical techniques like regression analysis. Regression analysis itself is used to identify relationships between variables so that we can predict future outcomes. Then we have other things like time series forecasting, Bayesian inferences. Those are the popular ones that you can use to uncover patterns and gain insights. We have machine learning, where we apply these algorithms such as clustering. Clustering is like grouping similar data points to uncover patterns. So I look at certain things to look pull them together and then examine them to uncover patterns. And then neural networks. Neural network is built like to mimic the brain. Learning. And like I said, machine learning itself is a branch of AI, right? Okay, so let me say this. It's a branch of AI but it does not lean itself to programming. Rather, it leans towards data, where we train the model or machine using the data. If you see this data, this is where you act. This data will make you act this way, right? So having that, we can use that to optimize our systems based on the data that we have. It doesn't require you to have knowledge of programming. It just for you to know the algorithm and how to train. But of course, we will see as we go. What you training a machine is like training a dog. If you train a dog to bite, it will bite. If you train a dog to sit, it will sit, unless where the wire will touch in the head. But training a machine is like training a dog. So we need to be careful with that. And we talked about data quality, right? So if you don't have the correct data, you will train your machine wrongly and you'll be doing the wrong thing. So neural networks, we use that to optimize processes and then automate decision making. Automation of decision making is where I'm talking about the dog thing. You train the machine. Now, when it learns, it's going to take decisions on its own. That is the purpose of teaching that machine. If you see temperature, go this way. If you see pressure, go this way, do this. The machine will learn. So whenever it's seeing that, that's the way it will react. Okay. Visualization tools, using interactive data visualization tools like Tableau, Power BI, D3 to present complex engineering data. Of course, there are a lot of other tools that you have these are the most, these are the ones I've worked with though. And these are the, for me personally, these are the most useful for me. Of course, for different applications, different people will use different things. Specifically for my area of expertise, these are the ones that help me most. Then big data technologies. I would like to look at big data on its own, but let's mention these technologies like Hadoop, Spark, NoSQL, and all that to process, analyze large-scale engineering data. So next page, please. Let's look at big data. What is big data? It's nothing. Big data is big data. That's how I that's how I define that, right? Big data is what it is. You know, we talked about the process of collecting, building a predictive model and using that workflow. We say collect the data, clean it up, and all that and all that. With big data systems, it doesn't care. We collect data, structured, semi-structured data, and the rest. If you like, let it be pages of newspaper, let it, insofar as digitized. It takes that and then turns it, extracts information. So big data is about having the power, the data analytics engine that can go into all this and extract information on its own. So how did this come, right? Basically, you'll find out that if you look at Facebook, do you know how many Facebook posts we have all over the world in a minute, 2 minutes? That data is stored somewhere. And because that data, so there's in big data, there's what we call velocity. The speed at which the data is generated is so much that you will not have the capability. You will not have the capability to analyze, to extract, to store, to clean, and all that. That's where the concept. That's why the concept of big data came, or big data analytics came. So the rise of big data has also helped to revolutionize the field of engineering. So what it does is it enables a data-driven decision making. So you are able to extract data from, so let's say, for instance, if you have that data from anywhere in the world, you have a certain type of electric motor and you know where to get that information. You can connect your system and your system can extract the performance data to help you also look at your own motor and see how you can optimize how it is. The downside of it is whether you have the powerful data analytics back end that you need to be able to do that analysis. But big data is the big thing right now. Is one of the biggest things in data analytics right now, because it is efficient. It gives you access to unlimited data. It comes with its own issues. We will look at those ethical issues, but it's the biggest thing right now. So you are not, if you are looking at, we're talking about road construction or bridge construction or anything. If you are looking at learning something and advance and innovating from what others have done, you have unlimited sources of information. With your big data engine, you can extract data from anywhere, analyze it. And the more even if you want to do machine learning, the more information you have, the more you'll be able to train that. So you will not see that your machine would have been like a machine that have gone to Harvard, because it has access to unlimited information. Okay. So let's go to, so after analyzing and all that, there's a part that we talked about. Next page, please. Thank you. There's a part we talked about communicating. At the end of the day, whatsoever you are analyzing, whatsoever, there's no need doing data analytics, doing everything, if you are not able to communicate what you have to your stakeholders. And this for me is one of the most important aspects of data analytics. There's no need analyzing if you cannot communicate. Because at the end of the day, you want to convince somebody. Or but like I will always say, after we finish everything, I'll say, well, put something there to confuse. Because if you cannot convince, what you want to do is to confuse. All you want is for the decision to be taken. So, but what you want to do is put up a convincing communication package to the stakeholders. And I have four tablets there. One is tell a story. Present your data in a compelling narrative. Look at that stakeholder. Look at what is important to that stakeholder. With your insights, paint a picture that will move. So if it's your boss, if it's your boss's boss, know what they want, know what they are, what fires them, so that you can tell your story to get your decision. Visualization matters. Use engaging graphics. So if you are talking about apple, don't go and put mango unless you are trying to draw a contrast. Okay, so you can use your dashboards. You can use you can do any visualization tool that works for you, but mostly it's dashboard. Keep it simple. Make sure that whatsoever information that you visualize is related to the story that you weaved. Then tailor that message, adapt your communication style and level of technical detail based on your audience. If you are doing it maybe to lower level management, basically they will want to know more. But if you are going to the board of directors, most of the guys in the board of directors are accountants or engineers. They are engineers of that have turned into businessmen, and what they want to hear is money. So what we are talking about, how is it going to affect the pockets of the people that you are talking to? Then focus on that, on impact. Emphasize how your analysis can drive meaningful business outcomes. How much money would it bring? How much efficiency? Link your findings directly to strategic objectives. So let's say, for instance, every company has the way they want to go. Some would say, oh, we want to make more money this year, or we want to expand our factory to so region. How is this thing you are doing going to affect that bottom line? How is it going to bring more money? How is it going to help? So for instance, we're talking about having an efficiency. Also, if we do this, we will be able to build more factories faster. This factory that we built, this is the analysis. We think that we could have done a better job. Now, because we are looking at expanding, if we apply this, we will be able to replicate this factory twice as fast as what we did before. That's a compelling case. And somebody will tell me, give me more detail. And then you can now, when they ask for more detail, remember we talked about tailoring, keeping it simple. When they ask for more detail, you have it at the back end, and you can show that. So there is no need for data analytics if you are not going to be able to present it. Next page, please. So so everything that has an advantage has issues, challenges on its own. So for data analytics in engineering, what I'm putting together there as strength is that it will improve decision making, enhance predictive maintenance, help you with real-time optimization of system and processes, like we looked at the case of the chemical engineering side, data-driven innovation or fact-driven innovation, like what I mentioned, and helps you to save costs. What are the weaknesses? I know I've mentioned this like 3 times. Data quality, data availability. The data has to be available, the quality has to be good. You need to have a skilled, you need to have skilled analysts. You need to, so when we're looking at, sometimes when we are you bring a data analytics engine or whatsoever you're doing, how does the engine or data sensors or whatsoever you are bringing today factor in to the machine of 1970? Or if you have not upgraded your computer systems, how am I going to adapt that? That's an issue. That's a weakness. Most of the, if you go to the factories, if you go to some of the engineering establishments, we are using old machines, old systems. We have cybersecurity concerns. When we're looking at big data, when you connect your system to the internet, somebody might want to hack into it. And when your systems are connected, it's simpler for someone to upload a virus that will shut you down. Then there are potential ethical issues with AI-driven automation. So, like we talked about machine learning, and we said it's a branch of AI. Now, so when we talked about training, when you train, like I said, you train a dog to bite, it will bite. If you show a dog that it should be biting children only, it will bite children only if you train it well. So if you train your AI, if you train your machine or your AI and you train what the data you are giving it is biased towards a certain process or a certain pattern, it is going to be biased. So one of the issues that we've seen around here is setting, for instance, setting AI that can discriminate by religion, discriminate by nationality, and all those kind of stuff. That's why we're talking about the ethical issues. Or some people can train AI that would go ahead to defraud the system. So who is training? What's the integrity of the guy that is even doing the back end for you? Okay, then the opportunities. Developing digital twins for simulation. I'm not going to talk about that. We have a page. Leveraging Internet of Things. That's one, and sensor data. Internet of Things is another thing that came some years ago, and what that talks about is machines interconnecting with themselves, talking to themselves, sending messages, receiving messages, and acting accordingly. So one of the big examples is a fridge, a digitized fridge. It has what do you call the compartments for each stuff, and it has a way of measuring by weight. It can count and all those kind of stuff. So you have it. If you put a crate of egg there, you can program it to talk to your computer and talk to Amazon or talk to your grocery store. When you remove like 2-3 eggs, right? You can say, okay, when out of 12 eggs, if I remove 6, order for 6 more. The system will automatically talk to your computer, and your computer will place an order for the egg for you. You don't need to do anything insofar as you had put in your credit card information. It would do it for you. So you also have cases for something like the Amazon Echo Dot. You can talk to it, and it can talk to all the lighting system in your house. You can talk to your stereo system. You can even turn off it. You can turn off your light. You can put on your security light. You can open your gate. So that's the idea behind Internet of Things. It has sensors and all that, automating workflow, improving sustainability and environmental impact, expanding into emerging engineering domains. The threat is the rapid changes in technology. When you do one today, another thing will come tomorrow. We have data privacy regulations. That there are some countries that will not allow you to give data to other people. Restriction on how you share data. And we have skill gap in the job market. So you find out that there are engineers that might not have data analytics skills. So that's a threat. So you will not be able to deploy data analytics as fast as you would wish. Then there are competition from technology companies encroaching on your domain. So let's say, for instance, we talked about engineering decision making. Somebody can come and tout that, okay, so if I am able to analyze this data, I can take engineering decision. Why do you need two engineers? Hire one. So a technology company that is able to have a system that can generate insights from engineering data becomes a threat. All right, next page, please. Sorry, I'll have to be fast from here. So some ethical consideration and best practices. First, ethical. So we talked about the ethical principles. We talked about privacy, transparency, fairness when collecting data. You have to be fair. If you like, okay, so let's talk about the like collecting data is like taking sensors, right? That's what the system is. So if you take data on good systems only and not take data on bad systems. So let's say, for instance, you have a plant and the data you are taking, you are entering data for the systems that are running efficiently only. The systems that are not running to the best of what you are looking for, you are not taking that data. The decisions you make will only cover the best systems. It will not cover the entire plant. Okay, so that's not a fair distribution of data collection. So when collecting data, you have to make sure that that data encompasses everything. When analyzing and applying that engineering data, we have to remember that we have to be fair around it. We have to uphold the ethical standard of that comes with engineering professionalism, right? Then the quality of data, making sure that we are thorough, that cleaning is thorough, and that validation is thorough. Okay. Responsible AI. We develop and deploy data-driven models that are unbiased. I already talked about the case of that dog. That is what AI is. What you train it to do is what it will do. It has to be explainable. So that's why we have that exploratory phase first. You have to look at it and make sure that you understand and that it makes sense. And then that it aligns with the organizational values, be it the company you're working for, your profession, the ethics of your profession, and all that. It has to align. Okay, so let's go to next page. Now, future trends. We've already talked about predictive maintenance, right? Or predictive models. You can So going forward, we are using it right now, but it's going to improve the ability to use machine learning and advanced analytics to predict equipment failure and optimize maintenance schedules. So you'll be able to improve your utilization, your reliability, and save yourself a lot of cost. Digital twin. You have a system. You can build that. You build that system in the online first. Okay, so in the computer generated system first. Put in all your operational parameters. You can run it for as long as you want, and make sure that when you make sure that you have it right, you replicate it. Now, if you need any improvements, you have a twin there. So instead of working your improvement or whatsoever you are doing and testing on the physical system, you go to that system. Data analytics would help us to a point that we will be able to have data points there that you can put in almost, like we said, technically, almost everything that the system on ground has, including external temperatures. You can put it there to see how it will behave. And then you can make your changes there and make sure that you run it and optimize it in that system. You can now get that model out. You can print out whatsoever is there and then come and implement it on the one on ground. Automated decision making, machine learning, AI-driven data analytics. So you'll be able to make faster, more informed decisions. Okay, streamlining engineering workflows, improving overall productivity. But at the end of the day, like we talked about automated decision making, the system can make decisions on its own. But you have to trust the data that you have put in, that you've trained it with. When this, then you now also have to differentiate what decision you want the system to make, because you don't want the machines to make decisions, all your decisions. There are certain critical ones that you need a prompt. It will prompt. That decision will be to prompt you to go and check and do something. That is very important. Differentiating what decisions the system can make. Data analytics will give you that capability. If you want the system to make decisions, AI is there now. Give it the data, tell it what to do. The system can learn and do it. It will do, it might not, it will do it repetitively better, because you will be distracted. The system cannot be distracted. But in terms of overall decision making, taking all other things into consideration, it might not. So it will be like a friend of mine that bought a car that time and now put in some music. They went somewhere, they were high, had an accident. The radio that was there did not recognize that they had an accident. The radio was still blasting the music that he was playing. Meanwhile, the guy was unconscious. So AI is like that. You tell it to do something, it will keep on playing that, like that radio. You will not know that their machine had caught fire. It will keep on pouring whatsoever fuel or whatsoever it was supposed to do into it, unless you have built that. So there are certain decisions that you need to halt and take by yourself. We can't hand over all decisions to data analytics engine. Then sustainability insights. Data analytics will provide engineers with deeper insights into energy consumption, emissions, environmental impact, enabling more sustainable design and optimization of engineering systems. Of course, that's where everybody's going. Building sustainable systems, building clean systems, building systems that don't cause pollution and don't cause the ice to melt. I don't know whether that affects Nigeria or not, but like doctor would say, what does not concern me will concern me. But that's where everybody is going. You can have that insight to build cleaner systems. All right, next page, please. I like the photo. People that are wearing hard hats, turning into someone wearing suits, anonymous person wearing suits. So this is a pitch from me to call some engineers to become data analysts. So, because as data analytics becomes important and increasingly useful in the field of engineering, we've talked about business analysts. Most business analysis experts are either computer science guys, information system guys, accountants, and all that. So, I mean, that's from what I have seen. But if we have to bring more of data analytics into engineering, who is in a better position to be able to interpret engineering problems and give solutions? Is an engineer. So if you have an engineer that understands the engineering part and now has developed himself to understand the data analytics part, it becomes a valuable resource. Yes, you may call him data analyst, you may call him data scientist, you may call him data engineer, business analyst, but at the end of the day, he's an engineer, someone that understands engineering problems, understands computers, data analytics, big data, all those kind of stuff, and then can stand in the middle and propose a solution. So apart from learning to become a data analyst, engineers can also do their own continuous learning, professional development in data analytics to gain more knowledge. There are free trainings to become data analyst is becoming free now. So you have Google, Coursera has some courses around that. So if you're interested, you can look that up. But I think it's best for engineers to be data analysts, either full-time or learn it as part of what they are doing, how to use data to solve engineering problems by themselves. In conclusion, I'll just read what is there, or I'll allow us to read it. So data analytics is a powerful tool for engineers to optimize processes, improve product performance, machine performance, engine performance, and drive innovation. It will always evolve. Data analytics will always evolve. So engineers must stay informed about latest tools, techniques, and best practices if you want to remain competitive. Engineering companies too, in fact, most companies will need to stay informed, because sometimes the difference between one company going up, another going down, might be what information or what data you collect and how you utilize that insight that you have. By leveraging data from various sources and applying advanced analytics techniques, engineers can make data-driven decisions. So it doesn't just have to be your plant. It doesn't just have to be your DC. You don't have to learn from yourself alone. Like we talked about big data, you can tap into data from anywhere for the same thing that you have and learn from it. Somebody said we cannot make all the mistakes by ourselves. That's why we learn from others. So by embracing data analytics, engineers can unlock the full potential of their data and create a more efficient, sustainable, and innovative future. I think we've come to the end of that's the last slide that I had. I'm sorry, it's like after I took more than 1 hour. I would have loved to take a full day, but unfortunately, that's where we stop. I will pause for questions, contributions. Thank you.
Yes, thank you very much, Mr. Odudu, for that masterful presentation on delivery of the today's webinar. I really have to say that your content packed a lot of punch, and I'm sure that that would have obviously stimulated or stirred many questions from participants and distinguished members who have joined into this webinar. So let me now say that at this juncture, we have now encroached into the last session or penultimate session of the webinar today, which will now involve the interaction between the participant and, of course, our webinar instructor. Hence, I will now kindly sift through the questions that have been addressed to our instructor today. Okay, so Mr. Instructor, please, are you ready to take the questions now?
Yes, please.
Okay, very well. So the first question we have here from, I beg your pardon. The first question we have here from Engineer Umoh reads, I see DA a sacrosanct requirement for production and general management in the engineering ecosystem. How can one get trained and how long will it take?
So the kind of training that you would need would depend on the field that you have to tailor it to the field that you are in. I am an advocate of development, self-development, people development, but I don't like to waste my trainings. So you have to tailor it. So it could be like 3 months, depending on what it is. You have to find, first of all, you have to find the tool that works for you. You have to, depending on what your background is too, you have to find what works for you as a person, what works for your own branch of engineering. You have to look at what data sets you are looking at, or you'll be looking at, and then you can now choose your own training. But 3 months is long enough if you are dedicated. But if you are like some of us that go out every day to go and fend for a living, it might take up to 6 months to 1 year.
All right, thank you very much. And by the way, you were just responding to that question from an agricultural engineer, I beg your pardon. So I suppose he must have taken 1 or 2 things away from your presentation.
Oh, so that's very good. Looking at an agric engineer, I think yeah. So it would be, so what he would be looking for, from my own experience, would be something that can. So first of all, like I said, depending on the data set, what it will be looking for is something that can analyze qualitative data mostly. So yeah, 3 months is enough. We can talk though.
Yeah, sure. Good afternoon, sir.
Yep.
Thank you so much. I mean, this is a very wonderful presentation. Like he said, rightly, I'm an agric engineer. I'm more of a fieldsman, production, so to say.
Mm-hmm.
You understand? So I think when we get to talk, I will try to see how we can tailor it around field production of specific crops.
Okay.
You know, on a large scale, commercialized production, you know, because people are not really doing agriculture, following the project management approach, and something I've been pushing.
Yeah.
You understand? I love this. Well done, sir. Okay. All right, sir.
Yes, thank you very much, Engineer Uwem. Please, after now, my dear, okay, I can see some hands raised. Let's go with let's go with Dr. Alabi. Thank you very much. Dr. Alabi, please ask the question.
Dr. Alabi, if you're asking, you are speaking to a muted mic.
Hello? Can you hear me now?
Yes,
Hello?
we can hear you now. Yes,
Yes,
Doc.
I can hear you.
Okay. Thank you so much, the presenter. Then a very big thanks to the organizers, NSCE and NSCHE. Please, the central point in your presentation revolves around data. And without data, we can't do anything analytic or modeling or every other thing you mentioned. Now, this is the challenge. If you want to work with data, most especially industrial data, and those who are not inside the industry, it's usually a Herculean task to be able to get real life data. Please, will you advise how one will be able to have it smoothly, to be able to get data from our industrial partners? Because sometimes you make a lot of effort, but they hardly. Probably since you've been working in this area for several years, how you've been able to go about it and you have been able to get some success may be of great help to those who are not inside the industry. Thank you.
Okay. So I think I like that question because at the end of the day, this is what it comes to. So two things. The first one, there are people that have there are researchers that have been able to go to several industries and they have banks of data. So if you align yourself to any one of them, so one of the things is you look for someone that is doing research in your field, and then you can align yourself and you can get data from there. The second one is there are commercial data brokers. So there are commercial, doctor, there are commercial data brokers. But what that would do is it will cost you money. But you have to be careful to be sure that the data you are getting is not AI generated, because anybody can generate any data for you. But there are real commercial data brokers who have gathered information from industries and use that. The other one is there are some engineering consultancy firms that are willing to share clean up data. The reason people don't like giving data is because they don't, they are especially when you are competing in the same space, they don't want that data to go into the hands of their competitors to be used for for what do you call it, to compete with them, right? But they allow engineering or consultancy firms or some other consultancy firms like NSE Young and all those ones. They gather those kind of data for analysis. And what they've done what they do with it is when they gather it, they will clean it up. They will remove all company references and make that data neutral. So when you receive it to do anything, you will not be able to identify what industry you are looking at. So if you can get a researcher, you can get information, because companies allow researchers to go do some things for them. If you can get engineering consultancy or general consultancy firms, in companies, industries trust them to handle the data well. Or if you have money and you see where to buy, you can buy it.
Okay, thank you very much to the instructor for that response. I want to actually defer back to Doctor if you are satisfied or you have a follow-up question.
Yeah, thank you very much. Those pieces of advice are very great. But I am thinking that rather than being a little bit restrictive, that is having an interface between the potential user of the data and then the companies should be able to have some what I can call bold attitude of allowing the potential user to interface with them. Because when I was outside the country and I did a research with a company and a university, I mean, there was no big deal. All you needed to do is to make sure you provide what you call a MOU, that's Memorandum of Understanding, and then the confidentiality documents. Then you sign that you are not going to open their confidential things, you know, to the public without their prior permission. And if there's anything you do outside that, then legal procedure can follow. And I think our Nigerian companies can also probably learn from that and then also have that bold approach so that they won't be pushing you away here and there. Sometimes you get tired. You don't want to even have anything to, after you've made some series of effort. In fact, if you apply to DPR, you know, to get some information, maybe from like at the end, you keep on making a lot of effort, and some of those researches are end up, you know, like it's a kind of stopping in between, and you just suspend them because of such situations. So if they can try those approaches and encourage them that when you sign with these people, they are mature people, they are academics. These are the people that also wants to protect their integrity, and they know the professional ethics, and there can be legal implication if they divulge the secret. I think we can make some progress from there. Thank you very much for your time.
Okay, Doctor. Thanks for that. Thanks for that clarification. I think I was speaking from the perspective of one industry to another. Okay. So if you are talking about research, there should be a provision to get that. So one of the things, what if you are not having that, that means maybe the approach, that's one of the things. So the question is, who in a company should be able to provide that particular service to you? Yes, you will sign an MOU, you sign a data privacy agreement that you are not going to, but it also, one of the things I have seen is that it also has to be something that is beneficial to that company. Whatsoever you are using, the company would release information for you to go and do work that they can benefit most of the time. And they will restrict you and they will give you whatsoever you are looking for, well defined. That's one thing. If they are not doing it, then there is an issue. So Nigerianizing the issue right now is that information that you are getting. You know, we write reports, we present it to the regulators and all that. If at the end of the day, I'm not doing what I'm supposed to do, I'm not going to give you my raw data because it's an exposure. So that's one of the issues that you will have. Let's say, for instance, you go to a chemical producing company and the effluent that they are supposed to dump into the river is supposed to be a certain part per million. But they've reported that, yes, we have met the regulation. If you go to those data points themselves, in their report, you'll see it. But if you go to those data points and they allow you access, your report, whatsoever you are doing, would show that it is not true. And the ethics of your own profession, doctor, might not allow you to lie or to give contrary listen to what other than what you have seen. So you will have those pushbacks sometimes. But in the end, I said all that to say this: if the company knows that they are going to gain from what your research is about, obviously they will grant you access. So that one that you are talking about, I can attest to it. If you go abroad, they're even the ones that would invite you to come and take data, analyze, and give them your own insights.
Okay, thank you very much, Mr. Odudu. And also I want to say thank you very much, Engineer Dem, for exercising the patience. I've seen your hand has been raised for quite some time. So you now have the floor to address or aim your question at the instructor. Thank you. Engineer Dem.
Yeah, good day all. I guess it's still morning, so good morning, everyone. I hope I'm being heard.
Yes,
yes,
Engineer,
we can hear you.
All right. So, well, I had tried to put my hand down when Dr. Labi was also talking about the data issue. But I think when our honorary speaker was making telling us about some of the nitty-gritties of trying to get data from the industry, I tend to agree with what he said regarding certain reasons for not getting data from the industry may be related to maybe some funny things going on in the companies, because you find out that, like you may just generalize that we may be able to get data if we align ourselves closer to the organization, or we specifically target certain parts of the organization and we may be able to get data. I tell you, in Nigeria, it's practically impossible to do that in, if I may say, close to maybe 70-80% of the organizations we have. And that may be because of certain secrets that are being kept from us. So I would have been thinking that, just like Dr. Labi has said, there should be some sort of policy shifts, within the country that allows women. It may not specifically be that we are able to target and get all the data from such organizations, but rather we may be able to get some what you call incomplete or something light on the side from the companies, and which researchers can actually build on to be able to use and in running some of these models. I think this is the major problem with data analytics in Nigeria. It's the issue of being able to collect data and being able to use them to do your analysis has really been the problem. So in most cases, a lot of people have to go into AI generated data, look at characteristics of data, and try to generate data that tries to fit the characteristics of the organization or the problem they are trying to solve. So I think for me, that's issue of changing the policy within the organization. We know we have the Freedom of Information Bill, but I tell you, it's not even working. When I was doing my PhD, I worked on a model. I had to abandon it, completed the model in 2 years, went to Lagos and spent 8 months and didn't get a single data. And I went to almost about probably 9 or 10 companies in Lagos. And what they tell me is that this you can have, this you cannot have, this is not, you just cannot get this. So this really has been the problem with data analytics. Thank you.
All right. So one of the other things is what they said you cannot have. Sometimes they're not even measuring it. So we buy. So sometimes we buy things, and the way we operate, we are not collecting. People don't collect the correct information or full retinue of information. So you can build your model, you can do everything, and you go to the industry and you say, "I'm looking for this." They are not keeping records. That's another thing. People don't keep records. So part of what they say you cannot have this might be that they don't even they are not even tracking it at all. What they want is they just operate, make profit, and leave. All right, thanks.
Yes, thank you very much, Mr. Instructor. I think I see the hand of Dr. Ezekiel Namere. Please, Dr. Ezekiel, may I aim your question to the instructor?
All right, thank you so much, moderator. I will start by thanking the presenter for an insightful presentation on the topic data analytics and applications in engineering practice. My name is Engineer Dr. Ezekiel Nameraneke from Port Harcourt branch of NSE. So I want to find out from the presenter, Mr. Presenter, you have done so well, but I want you to elaborate more on how data analytics can be integrated into the daily operations of engineering projects to improve efficiency and decision making. If you can throw more light on how this data analytics can be integrated in engineering processes.
Is it process or projects?
I hope I'm here.
Yes. Did you say projects or process?
Projects.
Okay.
Projects.
So let's start with the schedule that you have we have, right? So you have a big project, you have a schedule, and those schedules have parameters. you have start date, you have end date, you have milestones, you have you've built relationships for task, start to finish, finish to start, and all that. If you digitize that, if you automate that, so instead of somebody looking at sitting down and doing the analysis, if you can put that in a data analytics model, it will tell you. So all it needs to do is, okay, so let's measure what's the progress, where are we, what do we need to do to get to this point. It can calculate your lead time, your lag, and then show you the optimal way to optimize that schedule. That's one. In terms of quality, depending on what you want to measure, so that's another one, right? Depending on what you want to measure, the quality of work, the mixture of resources that you need. So I'm using let's say, for instance, you are paving, let's say, road. Let's talk about a road project. I'm mixing this, I'm mixing that. The strength of this is that you can use the system to simulate those mixtures, change the components, cement, sand, depending what quality of sand it is. If you use this type of sand, this is what strength you have. If you didn't, you estimate the number of vehicles, project the number of vehicles that will be passing through, the weight of the vehicles. If it's like this Odupani Calabar Road, you know that they will be carrying a lot of granite. You use that to optimize the quality of product, your final road. It will tell you, okay, so for this point, because the soil structure is like this, you need to be able to do this to be able to get the quality that you are looking for, to be able to carry this so number of vehicles that are of this weight, all those kind of things. So you can use that. You can use it to optimize quality. You can use that to quality of your product, your schedule. You can even use that to gain some efficiency around the finish dates. So, for instance, you are lagging behind your schedule in a certain way. You could go back to that model and say, okay, so I'm lagging behind. Given that I have to do this, what can I optimize to be able to meet up this timeline? It would tell you, okay, so if you want to optimize based on how you have been doing work, you can do prescriptive, you can do a bit of predictive based on how you have done in the past. For you to be able to finish this, you need to increase the number of people to this. You were using 2 tractors, you need to use 5. You were using 2 caterpillars, you need to do 5. You were using 3 graders, you need to optimize it to 6, and all that to be able to meet up that timeline. So a lot of ways you can use it. I don't know whether that makes sense to you, Doctor. Doctor.
Dr. Ezekiel, please. That question is.
Yes. I'm okay. Thank you so much. Thank you so much.
All right, Doctor.
Okay, so next. Yeah, Mr. Chairman, you have your hands raised. Please proceed with your question.
Okay, thank you very much, my very distinguished presenter. You've actually done justice to this topic. You've actually bear our minds in.
Yeah, Mr. Chairman, please, you're not audible.
Okay, are you with me?
Yes, we can hear you now.
Okay. I want to, by way of comments and suggestions, as well as some few questions to help us in seeing how we can be more effective and efficient in our practices. I want to tell us that data is money. I've seen the way people are reacting about why companies don't release their data. I want to say here and then that data is money. So for a company to give you its data, to them means that they are giving you money. So it takes someone that is with them for them to actually allow you to have such assets. So in order for us to have access to this data, I think the presenter had already done that. But I have this question to ask so that it will help us as engineers to use this workshop as a starting point moving forward. How can our organizations like NSC, like NSCHE and several organizations successfully transition from the traditional methods to a data-driven approach in engineering practices? And what are the key factors for successful implementation and adoption? Mr. Umoh, are you hearing me?
Yes, I'm hearing you.
Okay, did you hear the question?
Okay, so the question is, how can engineering organizations transition from traditional methods to data-driven
approaches in engineering practices, and what are the key factors for successful implementation and adoption?
Okay, so the first one is for you to want to do it. The first one is to make up your mind to want to do it. And that starts from, if you are like, okay, so let's take the NSC as an example. Somebody making that presentation and the people that have, because it will cost money to implement, well, I'll call it leadership, buying into it. The second one is assessing your current state, because if you don't know where you are, you may not know where you want to be. So where are we? What improvements do we want? The third one from the top of my head would be developing like a roadmap. So developing roadmap is like, so you are not going to get to, you may not be able to get to your peak performance or the zenith of data analytics by one implementation. For most organizations, it's incremental. So you have to develop a roadmap. You might need to get an expert to sit down with you, or you might want to get someone that has done some implementation to sit down with you to draw up how you want to proceed. Do you want to start small, incrementally, you add? Then, of course, from all the questions that we've had, we know that data is a problem. So you cannot even start data analytics without having your source of data. So what are you going to analyze? So if you look at maybe like a company or like your organization, what data do you have? Because you have to have data for you to be able to take advantage of the to be able to analyze, to take advantage of the insights from that data. And then you now have to maybe that's the first thing. So you have the project, the first project for you, so I'm answering the two questions at once. The first enabler is for you to have that data. So you might want to have a team of people that understand data. You now have to look at what forms you need to collect that data. Do you need to install sensors? And then when you have that, you've started. So it's like, so it won't be like the fact of building a factory without having raw material. Because if you jump the gun without having that raw material, which is data, your factory will just rot away. Okay. The next one would be now going to go and build, buy the computers, build the infrastructure that you need. The platforms, the tool, the hardware, the software. And when you have done all that, there is still one more thing. You know that data you collected and the infrastructure, you need to define usage, which takes us back to where we're talking about the ethics. You need to say, this is how we are going to use this. You need to define your policies, your procedures. And when you define your procedures that will guide the usage, what people will do, how we are going to be analyzing our data, what we will not do with this data, you also need to train your people. Because as it is, you will find out that what you did not have, people will not know how to use it. So training is important. And then you can now, like I said, you first of all, you need to develop that roadmap that you developed has to have something like a pilot. I start here. So let's say, for instance, if you have NSE Uyo, NSE in Port Harcourt, NSE in Calabar and Cross River State, and what you want to do is start small, build a small one, test it. It's called in our own kind of, in fact, in any kind of project management, it's called scaling. You scale it small, and then you can upscale. When this one works, we can now take it to this pilot works, we take it to the greater team. We can deploy it to everywhere. And that roadmap will also have to have the process of regular evaluation. Like I said, you can start small and then have add-ons that will take you to where you want. So you can start with a simple engine for data analytics, and then you can add dashboard, and then you can upgrade to AI models, because you may not be able to start everything at once. So continuous improvements. You improve upon it because you are going to learn on a daily basis. There will be new needs. There will be new equipment. There will be new processes that you have introduced. You have to upgrade, you have to high grade, there are things that you need to throw away, get new ones. There are things that you would have to improve upon. Okay. So in having said that, you might not be able to do everything as an organization on your own. So if you're a group of engineers, you will need people, that data scientists and data engineers. Whatever you are doing today, other people have done it before. So you might want to go and learn from what others have done. And then put money down. You need to put money down training your people on new technologies. You need it takes a lot of stuff. So for me, it starts from recognizing that what you have is inadequate. And then making sure that you build from the foundation up. And in this case, having that data first. So, and as I used an example, you don't build an industry on that you need raw material, and then before you now start looking for raw material. So you want to be processing cassava. You have not even planted cassava, you build a mill. And then you now start going to plant cassava. What if you now have a drought that the cassava will not come? Your mill will stay for 2 years without processing anything, and some of the parts will rot away. All right. So that's that. Did I answer your question, sir?
Yeah. Thank you very much for that insightful answer, but I want to add this to our fellow engineers. We are actually inundated with a lot of billions of data in different engineering sectors. And there are also lots of green fields in this engineering sector. One of it are the policies that have been churned out by the federal government, most especially the conversion of CNG in our cars, this presidential initiative on CNG. So that puts a picture of plans that should be put in place, from us engineers. And what the presidency is trying to do is to see how we can rejig the energy sector, which practically has several engineering professionals involved. And I would want to say, because it's a green field, from the answers that you've given us, that we as engineers need to put our axe on ground to start gathering those data. We can know that CNG is not something that had been practiced in our country, so it's a new thing. And the conversions have not been practiced in our country, it's a new thing. So we need to start studying from the mechanical engineer to the civil engineer, to the chemical engineer, the several other electrical engineers and several others, how we can track this trend, track this pattern, so that in the next 3 to 4 to 5 years, we can now start giving data-driven information to the governor, to the presidency, to the government that are real-time based. I think this is the new norm that we need to follow. And I believe if we follow this norm, we would be better engaged with government in discussing how issues are to be taken care of and how we can bring solutions to several bedeviling issues that are facing us in our different engineering sectors. So thank you very much, my presenter, and thank you for your answers.
Thank you, sir.
Yeah, yes, thank you very much, Mr. Chairman. Of course, time is of importance. So we will try to quickly round up proceedings. But I want to, although it's rarely said, but I want to now commend all participants and distinguished members, or distinguished members and participants, I beg your pardon, for maintaining decorum and also for being engaging with the instructor. I think so far we've really had it interesting and smooth, so we can all be happy about that. Then to mark the end of this penultimate session, session 3, I would now want to kindly invite the Technical Secretary, Uyo Branch, Engineer Aniete Basi, to give us some recommendations and pieces of information. Thank you.
Okay. Can you hear me?
Yes, we can hear you loud and clear. Thank you.
Okay, thank you so much, moderator, for today, this webinar. First of all, let me commend our lecturer and guest speaker today, Mr. Umoh. He has done a great job in delivering his lecture in data analytics and its application in engineering practice. Kudos to him. I have some recommendations here. Number one, I would like it that in subsequent workshops, we consider important areas such as cyber security, cloud computing, data science, machine learning, deep learning, neural networks, robotics, Internet of Things, and artificial intelligence as a whole. He has mentioned a few of these areas, but I would like us to consider it in depth in our subsequent webinars. Again, I want to believe that soft copy of this insightful and interesting seminar and workshop will be sent to all participants of this webinar. I want to believe that. Right? Hello?
Yeah,
yes, you already have it. You already have it, and it can be circulated.
Okay. Then lastly, though I've discussed this with the chairman of NSCHE, Engineer Chemist Rock, I would also like it that certificate of participation will be given to all the participants who will attend the practical session of this workshop, which is coming up soon. I want to believe that too.
Hello? Is that for me?
No, that's for the chairman, Engineer Chemist Rock, chairman of the Nigerian Society of Chemical Engineers.
Okay, thank you very much, my technical secretary, NSC. Definitely, we are looking into that. Like we had discussed earlier, we will take this lecture into the next phase, which is going to be the practical aspect. I think this is just the prelim and the intro into how effective data can be in making us more effective and efficient in our workstations. So we will move from here to the practical aspect, and a Google document will be sent to that effect to those of us that want to be part of that practical session, so that we can make adequate preparations in order for you to be comfortable when you are ready for the next phase. So thank you very much.
All right, thank you. That's all I have to contribute. Thank you so much.
Yes, thank you both, Technical Secretary. Thank you, Mr. Chairman. So we have now come to the end of the third session. We are now going to embark on the fourth session. And by way of precedent, because this webinar instructor has delivered an intellectually provocative, workshop session. So it is only, good as a way of appreciating our instructor to express our appreciation as a chapter and as a professional body, for his delivery. So to help us express the moment, I will kindly ask the chairman, NSCHE, Engineer Ikemesi Dorok, to do the needful to kindly express his appreciation to the instructor. Thank you.
Yeah, okay. Thank you very much, Engineer Uko. My instructor and my very distinguished friend, Mr. Odudu Umoh. On behalf of Nigerian Society of Chemical Engineers, Akwa Cross River State Chapter, in collaboration with our mother body, NSE Uyo Branch, this is giving to you a certificate of appreciation. And this certificate is awarded to you, Mr. Odudu Umoh, for your outstanding technical lecture delivery on data analytics and applications in engineering practice during our June 2024 workshop presented on 1st June 2024. Please accept our congratulations, and we look forward to the second phase, which is going to be practical for you to also engage us. Thank you very much.
Thank you very much. Thank you, sir.
Okay, thank you very much, Mr. Chairman, and thank you once more, Mr. Instructor. So at this juncture, I would like the chairman, NSCHE Akwa Cross Chapter, Engineer Ikemesi Dorok, to now give us his closing remark. Mr. Chairman.
Thank you very much, my coordinator. Please, do we still have NSC chairman, Engineer Uwemekpan, FNSC?
So, Mr. Chairman, I think by my watch, I believe that he had departed us before now.
I had wanted him to say a word or two. Thank you very much once again. I want to appreciate each and every one of us that have made out their time to be part of this very insightful workshop in trying to engage their knowledge and expertise and improving on them, this workshop wouldn't have been what it is without the knowledge that you brought to bear, without your appearance and the insight, suggestions, comments. It is by gathering all those information that will make us to improve our processes, make us to improve our engagement. I really want to thank you very much. I also want to appreciate the NSE National and also NSCHE National for also being part of this team. I want to appreciate all the academicians that are here, the doctors, the professors, the industry players that have made this workshop a very promising engagement. So on behalf of Nigerian Society of Chemical Engineers, I want to wish each and every one of you a very fruitful new month and very enterprising new week. Thank you very much. So we'll be looking up to have you in our next series come when it is sent to you. So thank you very much.
Thank you, Mr. Chairman, for that address. And that marks the ending of proceedings today. But of course, by tradition, we would like to end the workshop with a closing prayer. And by no particular basis, I would like to call upon Engineer Mrs. Mpono Bangamadi to lead us in the closing prayer. Mrs. Mpono, please.
Okay. Thank you very much for this privilege. Thank you. So please, may we be in the mood of prayer, please. I'm actually on the road. In Jesus' name, our dear Lord, we thank you for today. Thank you for this privilege for us to come together to learn, to expand our knowledge. We also thank you for the strength and the grace, the wisdom you gave to today's speaker. Father, we pray for your blessings and more wisdom. And we pray that in our career, you will help us and help us to go higher and also expand our knowledge in our careers in the name of Jesus. We pray that you continue to bless NSCHE and NSE at large and be with us and help us to grow every day. In Jesus' mighty name we have prayed. Amen.
Amen.
Yes. Thank you very much, Mrs. Mpono, for that powerful prayer. And now we have come to the end of proceedings. I want to now kindly say thank you very much to our distinguished members, representatives of NSC, NSCHE, all participants that have taken their time to join into this webinar. For those that didn't join us from home, I wish you all a safe return to your respective abodes. And from here, thank you until we meet in the second webinar series. Goodbye.
Thank you. Thank you. I appreciate it. Thank you.
Thank you. Thank you.
So you can drop your email addresses. We'll pick them so that we can forward the presentation to your mailboxes.
Yes, please kindly drop your addresses so that. Yes, exactly. So thank you very much. Kindly drop your email addresses to receive webinar slides. Thank you.